Welcome everyone to another CP Tap call. This is call number 163. I'm pleased to introduce our speaker today, Tom Hildebrand from Ubiquiti. Tom has been a solution architect at Ubiquiti for past 4 years, where he focuses on product and product R&D. His work spans Wi-Fi, local network design, product design, and customer support, giving him both a deep technical perspective and practical understanding of how networking products are deployed in the real world. Today, Tom will talk about UniFi ProAV switching and how it brings GPS-based grandmaster, boundary clock, and transparent clock capabilities to UniFi Portfolio for the first time. This is an exciting topic for our community because it connects the precision time networking infrastructure and practical deployments in modern AV and enterprise environments. With that, I'd like to welcome Tom and hand it over to him. Tom, thank you for joining us. The floor is yours.
All right. Well, thank you so much. Thanks for thanks for inviting me, and thanks for putting this on. So I'm here to talk to you guys sort of about UniFi and our new ProAV switching, and how we've really sort of embraced PTP clocking. This is a new step for us. This is a new feature for us, and sort of how we see it fitting in with our own customer base. But of course, we're interested to hear how you all would use this, or how you would like to see PTP keep growing within our stack. So from our perspective, what we see a lot with our customers is that AV and IT are really starting to overlap. So what used to be a separate AV team that would do conference room networking or would do PA work, now that's all being rolled into your corporate IT department. And so now there's operational expectations that come with that. You have analog matrices, old analog video matrices that are now being replaced with IP-based solutions. You have audio and video now going over the same networking fabric that everything else does. Let's get rid of my own video here. You have AV integrators going to now AV and IT ownership. So now, because everything is now over a shared fabric, you now have everyone reliant on the core networking to be stable, and now the core networking to deliver reliable, consistent latency for those AV applications, which is something entirely new for all of us. Then you have always on infrastructure. It used to be you just roll up an AV setup, every time you need it, right? But now, because this is part of always on infrastructure, your network is now carrying that AV backbone. It now has to be managed, monitored, SLA'd like everything else. And so that's a big transformational push. And we see it a lot from AV integrators, both at the commercial scale, at the residential scale, all over. So where does that leave us now? Traditional AV over IP is the scaling problem, right? When you look at a lot of AV-centric equipment, a lot of AV-centric switches, a lot of AV-centric endpoints, the configuration is tedious. You have to hand configure IGMP snooping on every single switch, configure query elections, QoS classes, multicast routing. You are spending a lot of your time as a network engineer hand tuning all of this per port, per room, and it just grows to be an operational nightmare. Then we get into clocking challenges. So you're all very well familiar with how PTP works, PTP-v2. I don't have to explain much of this to you, thankfully. But for a lot of users, for a lot of network engineers, the question becomes, what kind of clocking do I need? Does my switch support transparent clocking? Does it support boundary clocking? Do I need boundary clocking for this deployment to work? It introduces a whole new set of terminology that a lot of network engineers are just not familiar with. And even if they are, finding a switch that is capable of doing that while meeting other operational requirements is a challenge. Then you have the fragmented management perspective. Like I said, you're sort of rolling legacy AV teams into your network team. So you have different styles of change notifications, different styles of note taking, and where your configurations live, where your documentation lives, different control planes. Like if I just bring in my AV team and they're using one brand of switch, we use another. Now I have two separate stacks that I have to contend with. It becomes a scaling nightmare. And then don't forget the license gated features too. So as a lot of people in traditional networking are aware, you're paying licensing fees ongoing every year. And now, even if you buy AV centric stuff, which is designed to work offline or designed to be on a air gap network, you're still buying license enablements for features, or you're still paying for um, support contracts just to get firmware updates. All of these renewals, these hidden fees, they add on to a cost that's definitely appreciable for a lot of networks and a lot of companies. And so when companies are being pushed to simplify, um, to reduce headcount, to reduce operational expense, the license gated features sneak up on you. So UniFi ProAV brings all of these AV centric requirements, all of these PTP requirements to UniFi Network for the first time. And so what makes us different? We have seamless configuration in minutes. If you're familiar with UniFi, if you've ever used UniFi products before, we take great pains to make an easy to use and elegant GUI for the vast majority of operations. Here, for example, this is our configuration page for setting a port's QoS. Now you can go into custom, set your DSCP values, set your traffic queues by hand, or you can just pick one of these options. If I'm configuring a bunch of Dante endpoints, you could do that. If you're configuring NDI, ST2110, you can do that too, including this nice handy PTP checkbox underneath. But of course, we know there's much more to PTP. This is the exciting part, and I'm actually going to get out of the way of this one. This is the PTP configuration. It is auto-framing me. I don't like that. This is the PTP configuration. And what this allows us to do is on each of our ProAV switches, which I'll talk about the next slide, there is an inbuilt GPS-based grandmaster clock. So you can set the clock priority. You can pick a pre-made profile, whether you need it for SMPTE, AES67, or if you want to be able to set a custom clock of your own design. So setting the sync interval, announce interval, the domain, how you want it transported, what the delay compensation should be. So if I'm running a GPS antenna to the roof, how long is the cable? So I can compensate for that level of precision. This is the first UniFi switch that features this. And I'll show you where the SMA connector is in the back. It makes setting up PTP for a network just a cinch. And then finally, it's one consistent management interface for all of our products. No matter whether you're just getting into us for this AV switching, whether you want to get into us for Wi-Fi, for your entire network gateway, VoIP, storage, security systems, UPSs, everything is contained in the UniFi umbrella, all centralized, all license-free. Even if you run 10 sites, 20 sites, 100 sites, it's all managed centrally on unifi.ui.com, and you are able to build now what we call fabrics. So you can templatize things, you can build out VLAN configurations, all of that write once, push to many. We even have API access now, as well as Ansible playbooks. But I've talked enough about the management perspective. Let's talk about the actual switches.
Apologies. Is there supposed to be audio accompanied with that?
There should have been audio, but I guess I set it to display audio, but I guess it didn't run through.
Yeah, but
My
if we have enough
apologies.
time,
And
it may be worth just resharing it and replay it.
yeah, I'll give that a shot. But yeah, I also wanted to mention while I have attention that we now have a partner program. So for doing these kinds of large scale installations with our AV switches, or just building out a large unified project in general, our partner program is a great place to go. So we connect you with large project pre-sales. So I'm involved with that team. We also have training, partner pricing, phone support available, and certifications. It's all free to join. Um, there's no sales minimums or anything. Just go to partner.ui.com to sign up. And so here are the actual AV switches. So we have two models right now, EAV XG24 PoE and the EAV Fiber. The fiber is meant to be a specialized one. We use that for stadium deployments, concerts, things like that, where they need that long run, right? Because you can put a 10-kilometer optic in this and go. But for general purpose use, the XG24 PoE is the one that I recommend. So that has 24 10 gig PoE triple plus ports, so 90-watt PoE delivery per port, 400G QSFP 28 ports, 2150 watts of PoE if you give it 240 volt power. And both switches support PTP-v2, hot swap fan, hot swap PSU. They have out of band management, console ports, and then right over here where my mouse is, you can see it right above my head. There is the SMA connector. So that is where you would connect a GPS antenna. And once you do that, then the switches can pull timing, and then you can set them up as your grandmaster or your boundary clock. And of course, if you do already have clocking sources, you can also set them to be transparent as well. But it's not all about clocking too. It's also about IGMP snooping. So being able to configure this easily and be able to make this scalable. So this is the IGMP configuration for my own home lab. And whether I'm doing this, whether I'm doing it for a stadium, same rules apply. I can set all of my networks at once. I can elect my queries all at once. These settings are then pushed to every single switch on the network. So now that I have a universally defined unknown multicast forwarding behavior, I have universal flooding behavior. I now have a primary and a failover querier set. I don't have to go diving into every single switch to configure them. I don't have to spreadsheet out everything. This is just a few clicks to get my network behaving exactly how I want it. And even if I just want to keep IGMP segregated, no problem. Down at the bottom, I can set specific switches I do want this to apply to. And so also to go with our EAV switching, we introduced our own little endpoint. These are fun. These are little 4K 60 HDMI endpoints, the EAV bridge. And they also feature XLR audio, including phantom power out. So they're super neat to do if you need just quickly scalable HDMI or audio distribution. You can even set up an 8x8 video wall with them. At our trade shows, we usually run one of those, all off of these AV bridges. So they're fun to play with, but they also do serve a really nice professional need where if I just need simple video distribution, I have some light USB distribution, some IR distribution too, for controlling endpoints, all of that just over the network. These are running, I believe, Dante Video. So these do take advantage of having a defined clocking source on the network. While it's not required to use EAV bridges with our switches, I do recommend having at least a good clocking source, if not running them on the EAV switches. And so this is just an example of the GUI. Like I said, we're GUI first on everything that we do. So being able to go in here and map your inputs, map your outputs, scale your video walls, all super slick, all inside of UniFi. And so where we see our ProAV model going, where we see a lot of it being deployed, are four primary verticals: education, stadiums, hospitality, and corporate offices. So for education, that's where I came from. Before I worked for Ubiquiti, I worked in networking for a large university. And we had distributed. We had a primary campus network, but every single classroom had a bespoke AV network, usually just a small separate gateway, some switching, HDMI matrices. It was just a mess to maintain that. So now being able to run it all over a networking fabric, but be able to keep that traffic segregated yet low latency is a really powerful thing. So in the lecture halls, I checked in with my old employer. They're now using Dante for distributing that live audio or for running additional speakers through a building. Same deal that you would do for any sort of live production or stadium work. The difference between education and stadiums, though, is the distance. Regularly, when I work in stadiums, we're running over 300 feet. We're running past the Ethernet limits. And so that's where we start getting into fiber distribution, aggregation, going across multiple switches, needing to make sure that transparent clocking at least is good enough. And they're running a multitude of different protocols they need to keep safe with QoS, right? So you've got your Dante and your AES67 for your audio. Then you've got your NDI, your ST2110. Usually you keep those segregated. Usually those run separate networks, but it's still something to be aware of, especially at the aggregation layer. Then you get into sort of hospitality, the high-end residential, because those networks sort of blur together as well. That's where we're seeing a lot more interest in things like HDMI distribution for room-level AV, conference spaces, lobbies, being able to share or blueprintize that configuration across multiple buildings, multiple developments, or in general, just being able to route video where a person is. And so that's where we get into SDVOE, and that's why we work a lot with SDVOE Alliance on endpoints and on qualification. And then finally, there's the corporate style, right? That's where you're building out huddle rooms, broadcast through a building for things like a PA, digital signage. You're wanting one stack, and a lot of companies I know use Crestron, they'll use Control4, they'll use AMX, they'll use a multitude of solutions, but Crestron, at least I can say that we're fully NAX NVX certified, and we work with them a lot. We're hand in hand with their support as well. So rolling us out for Crestron, even if Crestron doesn't use anything PTP aware at this time, we're still certified on the vast majority of our switches. And so these are just a handful of the companies that use us and a handful of the testimonials about from users who've adopted these switches, who use them in their own deployments. We have AV integrators, we have professional stadium work, we have people that do this for small companies, people that do this for broadcasters. We're all over the place. You've probably seen a lot more of our Wi-Fi than our switching, but I can promise you we're in a lot more places than you think. And so really the big takeaway, if I had to leave you with one thing, I know I give you 6 here, but if I had to leave you with one thing, is that we're now bringing this managed, integrated grandmaster and boundary clocking to your LAN. For the first time in the UniFi world, we now have control over precision clocking and configuration of the precision clocking all within a simple GUI that fits with everything else. We bring that AV-centric, is how it was originally envisioned, but that sort of design to modern IT operations. No more silos, no more separate network stacks, no more separate infrastructure that you have to maintain. Everything is single pane of glass. Whether you're doing centralized management of Wi-Fi, switching, fiber aggregation, endpoint distribution, all of that license-free, just one-click operation, one-click configuration, and it scales with your business and your needs. So that is all I have. I'm going to try to replay our marketing video and see if I can get audio working through a share. Oh, that's the problem, is unclicked. See if we can hear it now. We good?
We're good. Thank you.
Ethernet was built for efficiency. not perfection. And in most networks, small latency variation goes unnoticed. But for audio and video, those tiny delays become impossible to ignore. That's where UniFi Enterprise Audio Video Switching comes in. Powered by deterministic, precise timing. Every hop is measured and corrected in real time, so every device shares the same clock and executes in perfect sync. The result? Sub-microsecond synchronization. Perfectly aligned video, phase-accurate audio, and a network that feels flawless. With UniFi Network 10.0, you will see it. Visualize latency across your entire topology. Rewind history with Time Machine. And with the upcoming multicast analyzer, optimize IGMP to keep your AV network performing at its peak. UniFi EAV switching fully supports popular industry standards, including SMPTE ST2110, Dante, AES67, and SDVoE. Tired of stitching together complex systems? Meet the UniFi EAV Bridge. Designed for EAV switching and precision timing, this single device sends or receives 4K HDMI over Ethernet, taking your source to screens at any scale. Or use that same bridge for professional XLR audio with total scalability. From a single room to a stadium, perfectly in sync. Ubiquity, rethinking IT.
So that is all that I have for a rehearsed presentation. I'm happy to take questions now or explain anything else, go back over anything. Just let me know.
Wonderful. Yeah. Thank you very much, Tom. So maybe I can start with a question, relatively important, let's say, to our community is with regards to resilience, like that unit that becomes a grandmaster. What is the oscillator that's on it? Would it accept, let's say, a 10 megahertz input from, let's say, a rubidium clock or something like that? Like, is there more details about it?
In terms of the hardware, I would have to really dig in to what oscillator is on the board. If you're looking to pipe in an external oscillator, though, wouldn't you? I'd probably just set it to boundary and use an external clocking source. In general, I believe I'm trying to think what I'm allowed to say. This is, I believe, an AccuTime module that's on board. But details beyond that, I'm not sure of.
Yeah. And then the other one is the GPS. Like, is it what band is it? Like, how much configuration we have? Like, these are basically the things that are folks in this community extremely interested in.
Oh yeah, 100%. I'm thinking what I'm allowed to say.
Yeah, that's okay. Take your time.
One thing that may help is if you can't go through the full details, but you're allowed to say like what GPS receiver it is. Typically, there's only a few that most of the vendors that integrate GPS tend to use.
Yeah, like I said, it's an AccuTime module. I know that for sure.
Okay. We're not putting under pressure. That's okay. Another thing the last thing is like on the endpoint, it will be great also if the products were able to, let's say, give a PPS output. It will be great for this community. I mean, like mainly audio video, and you just have like, everything just, curated for the mainstream. But this community always looks for, even though if you don't use it, this community believes in synchronization when they can measure it. So
by all means, that's part of why I'm here. We introduced this product, we created this product for our AV customers.
Yes.
But from speaking to Ahmad at one of our trade shows, I learned that there's plenty of opportunity, plenty of interest in using PTP support for plenty of other projects on the LAN besides AV. And so I'm here for market feedback. I'm here for development feedback. So if you do have any suggestions that you'd like to see the product do, that you'd like to see us do with the existing hardware, please let me know.
For sure. Yeah.
Another one that could be of interest to consider is the industrial market. One of the big issues with getting PTP is, well, how do you do it where you don't necessarily need high bandwidth, but you do want to use it to synchronize everything? There, I'm guessing some of these would probably be too costly because they are targeting high bandwidth 10 gig needed for these, especially for video. But if you're just trying to coordinate, for example, robots or other things, but you want very precise timing, that could be useful. It could be a good market for you guys.
Yeah, that's interesting. Bringing this clocking down to something like a gigabit switch or an industrial switch.
Gigabit or even 10-100 and then couple it with PoE. You could also think like in some cases scientific applications. If you just want distributed sensor networks, what I'm working on right now is beamforming. So you have many software-defined radios gathering data, things like that.
Yeah, that would be interesting.
But that's always the frustrating part is typically it's like you're trying to interface it with like a $10 to $100 device, but then it's like, well, is it really worth plugging this into a several $1,000 switch? And it's just that there historically wasn't that much of a, or I don't even say not much of a market, but that many vendors, at least when I've looked in the past, of trying to find PDP-enabled switches because it is relatively niche. You get this chicken and the egg, but there just weren't that many options. So I'm thrilled to see that there are other vendors getting into the space.
All right.
Right.
Bob, let's see, Bob, do you want to add something?
Customers are like this. So if you look at it, which one actually-
Yes. I had a quick question. Applaud the work you've done to get IGMP simplified at layer 2. Is there any future interest in doing that at layer 3 for multicast routing?
Right? But they're different
Oh
layers.
yeah, absolutely there is. We're sort of in an earlier stage of that, but we're looking at it right now for sure.
It's a can of worms.
It is. It's a huge can of worms. Yeah.
I'll be impressed if you can bring the simplicity, that you brought to layer 2 up to layer 3. That'd be great.
Right?
Hisham?
That's how it's
Yeah,
structured. But
I
sure,
missed
this was different. So
the IGMB snooping.
like
Are you can maybe explain?
very
I
early,
know IGMB snooping, but what do you do with it?
they are more into
Are you
hardware.
improving it or you are using it for something?
You see that, right?
Yeah. In general, for the AV customers that the switch was targeted for, IGMP snooping is indispensable for doing any sort of scaled AV deployment. And we tried to make it as simple as possible because, again, a lot of our core customer base are sort of not AV integrators or into AV by profession. They've sort of had AV thrust upon them just by consolidation of IT departments and corporate need and everything else. So we tried to make configuration as simple as possible. Like, oh, I need a querier. Oh, here's where I set it. Oh, here's where I can set a failover. Okay, I'll just let it figure out how it handles unknown traffic. Or, oh, I said something about I need to set fast leave. Okay, here. We wanted to make the options both as easy to understand as possible, put them all in one place for all of your switches, whether you're deploying 1 or 100, and then finally give all of these little helpful mouse over things. So if you are unfamiliar with what that option does, or you're unfamiliar with how IGMP snooping works in general, be able to give our users some helpful background without making them read through KBs.
So you are simplifying IGMB snooping, correct?
Correct, yeah.
But what this has to do with time synchronization?
Well, for the AV-centric protocols that the switch was designed for, like SMPTE 2110 or even Dante or SDVOE, they sort of go hand in hand. The ability to have a defined clocking source on the network from these switches is important, but also these switches then knowing how to set up multicast groups between the products is just as important. So for an AV-centric customer, they need both. And the products need to support both, and we need to give a good experience for setting up both.
So you are simplifying multicast in general.
In general, yeah.
And I really need to learn more about exactly what you do here.
Hey, Shem, just as an example, imagine you're in a stadium with like thousands of different speakers and you want to time it so that certain audio data is leaving each of them in phase or at some degree of phase. You can't just have sort of random packets going around the way you typically would. So this is another interesting use case for this. Different from the area I think a lot of us do, but I have talked to other engineers telling me like they worked on the project specifically for Metallica to try to get it absolutely perfect with these very large, complicated systems. Because if you're multiplexing, I just an example. Imagine you have an ultra high res camera, and then you're trying to display that using, 64 TVs stitched together, you need to make sure all the frames are arriving synchronously and showing at the same time, and you don't get things out of order or stitched with different frames.
Right.
Uh,
And then
it is-
on top of that, it's also making sure that that data stream, if you are dealing with a high res camera feed that then you're sending out to different endpoints, you got to make sure it's only going out on those ports. Otherwise, you're going to start saturating uplinks, or you're going to choke out every other connection on the switch.
yeah, what IGMB Snoopy does.
Right.
Yeah, so you are using it to support your use case. But
Mhm.
what David is talking about is synchronizing all these frames.
Right.
So it works hand in hand with time synchronization. That is what you are doing.
Yeah.
Right?
So here I'll dive out of the way. So if you're doing something like SMPTE or you're doing AES 67,
Yeah.
which are AV centric protocols, you need both. You
Mm.
absolutely need both. The QoS or all three parts work together. QoS for prioritization, IGMP snooping for making sure that the packets go just to the right ports, and then time synchronization to make sure that the right packets arrive at the right time.
Got it. You need, yes. It is a component of the overall solution. Yes.
Mhm.
Well, in
And
my understanding, sorry, let me jump in
and
for just one sec there, Hasham.
and what
Uh,
Bob mentioned is really makes sense. And now BIM sparse mode and BIM dense mode. How you how you how you simplify those? Those are not. These are difficult protocols, not simple one to implement.
They are, and we're still working on and iterating on support for, I believe, PIM dense.
Yeah.
That's it's tricky. It's like you said, it's very tricky. So like we still have some multicast features in progress. So keep watching this space for sure.
Okay. Sorry, Bob. You can go ahead.
No, please.
Oh,
Please,
yeah.
this is a good question.
Sparse is
So
even harder because of the rendezvous points and all that stuff. Yeah. But
exactly.
yeah.
I agree.
So just conceptually, I think the three keys that you pointed out there, as my understanding of these AV applications, is that you're using time sync to control what I would call the release of the buffering at the endpoints. So you're really not using time sync to make sure the packets arrive, quote, when they're supposed to arrive. QoS makes sure that they're arriving
Right.
without contention, right? But there's going to be some low jitter paths, some high jitter paths, things like that. But inside of each of the exit devices, you've got a replay buffer that is looking at, when to release the next frame of video, when to release the next, into the next bits into the DAC, right? And that's where you need the time sync, is to keep all the DACs and all the HDMI guys playing in sync, is my understanding. And that's
Yeah,
the third leg of the stool, is getting the replay synchronized across exit devices.
That's
Yeah.
correct. That's a better
Okay.
way of putting it.
Oh, very good, Bob. That explains it to me. Thank you.
Okay. So,
Thank you.
well, it
That's
is.
what I'm looking for. Because I know IGMB Snooping, but what Bob is saying is correct. Relieving buffer has to be synchronized. And this is where you need time synchronization, but IGMB Snooping is needed anyway in any layer 2 multicast as an optimization. So thanks, Bob. Now I got it.
Yes. Yes. Well, it's I've had a job like Tom's in the past where I had to explain multicast and other things to customers who just wanted a means to an end, make my network work, and it's a challenge
yeah.
to cut through all the layers of abstraction and explain why you need each of these three pieces to make the end result you want. Well, good
And
job.
yeah, and to continue, and that will be interesting really to know how you do it. And also, are you going to only focus on PIM, or also you will look at DVMRB?
Right now, only looking
Only PIM.
at PIM, but like I said, that's why I'm here. I want to learn more about what we can do.
Okay,
I
if you
want
look,
to fill out the roadmap.
you might as well look into DVMRB too, if you are going to look at layer 3 multicast, IP multicast.
Yeah.
Put your email address on the chat. We can have discussion on this.
Yeah, please.
Yeah, Put it in this.
I'll put it in the chat right now.
Yeah.
So one important thing, like I was thinking is, do we have visibility on the servo, the parameter of the servo, all of this, or is just transparent to? I mean, it's like what do you call it? It's like just done on a layer user cannot see.
What sort of visibility would you like to see?
For example, let's
Because
say, yeah, sorry.
I'm trying to work on UX design to surface more, at least for a diagnostic perspective,
Mhm.
out of the switch. But I'm curious what parameters you would like to see.
For example, it would be great if you can choose between pi filter or a linear filter, or like there are some other Kalman-based filters. I mean, I work on servos. And then let's say certain parameters you can set. I mean, maybe in audio video, you don't have that much of a need because you can have one size fits all. But let's say when you have data and like, we come to datacom, things can go crazy. So like the nature of the system is different. So you need, let's say, more resilience versus more performance, something like that. I mean, you can simplify it to a knob resilience to performance and be done with it.
Right.
But I mean, it also you have to look at the characteristics of the oscillator, like both the local oscillators and the grandmaster and like the source of it and so on. I mean, this is like when you go nitpicking, there will be a lot of details then.
Well,
We can
one of the ways to
definitely
get one of the ways to get inspiration for what some customers may want, especially outside the AV space, is just look at the open source PDP Grand Daemon implementations, and you can just see what are all the variables they did to output to logging, and then typically they're there because customers requested it. So I'd look at like PDP4L, SF and so they have different stats, like what are the frequency offsets, how often are you doing PDP, different parameterizations.
And
Like
another
Ahmed
one
was
is like
mentioning, like what are the different
interoperability.
filters?
Yeah, the interoperability, I think you kind of mentioned, like, let's say you can accept a standard, let's say grandmaster, let's say from Meinberg or from, I don't know, someone else, like I'm assuming you can, right? So like
Yes, you can.
interoperability is perfect. Yeah.
Yep, and then you can set, if you want to interoperate this with other switches, you can set it to transport over just IPv4 or over layer 2.
Mhm, mhm. And then the transparent clock, do you have details as well as like a P2P, E2E, like all of these things you have, like, do you have any details of that?
Of how the transparent clock is configured. I don't at this time.
Yeah, got it.
Is the
I would-
beast that I bought like capable to do transparent clock?
Yeah, didn't we? I believe we tested that at the trade
No, we
show. didn't
tested
we?
boundary clock, not
tested boundary,
transparent.
right?
Yeah, boundary,
But-
yeah.
Transparent, I would have to check the. You're talking just land side.
Yeah, I mean L2 transparent, right?
It should be able to. I'd have to check the data sheet
Yeah,
for it.
I
It's not-
will follow up that with you because
Yeah.
that's literally the big deal. Boundary clock is kind of like all you need is like hardware timestamping on the both side. You have a servo like incoming and like pushing further. But transparent clock is a real deal. Like either you can do it or not because the ASIC has to be involved and with a correction field and like all of these things. So
Right, and hey, even boundary clocking is still difficult because not only does the ASIC have to be involved, but the switching firmware has to allow you to insert
Yeah.
that timestamp.
No, I mean you can create boundary clock with, let's say, a machine with a bunch of NICs completely like
Oh yeah. You
discrete
can
and-
add a boundary clock. Yeah. But
Yeah,
the
yeah.
question is, does the switch then really?
Yeah. And then the packet switching sucks, of course. Like if you just do it with a bunch of NICs, CPU gets involved, right? It becomes a layer 3. But then if you want to do transparent clock, you're out of luck with that.
Yeah.
So I think Casper wanted to ask a question. Casper,
Yes, I was thinking, like,
go ahead.
do you know what the accuracy is for boundary and transparent clock? Like, how many nanoseconds? As I saw some numbers in the video, but the voice just said sub-microseconds. I'm just wondering, like, how precise is the time?
I believe our accuracy was on the order of, it's been a while, 100 to 200 nanoseconds.
Okay.
That's feasible, I guess. Yeah. Hisham?
Yeah. The case of Wi-Fi where
Oh, yeah. Thank
we
you.
have an access point, and then you have clients associated with an access point, and those guys may roam from one access point to the other. How you synchronize the release of buffers on the roaming clients to that, as Bob mentioned, will be released at the same time. Because association between a client and an access point takes time. And it depends on whether you do make before you break or you break before make. You know how you do the roaming. So how that is taken into consideration to ensure buffers are released at the same time on all these clients.
Hisham
Roaming.
opened can of the worms.
Yeah, I was gonna say multicast over Wi-Fi is a huge can of worms.
Yes.
Because how it's handled typically on Wi-Fi, Wi-Fi is always break before make roaming.
Yeah.
So you will always disconnect from an AP before you then connect to another one. Until Wi-Fi 8 happens, then we're gonna have cool stuff happen.
Actually, vice versa. You make before you break. You
Mhm.
associate ahead of time with a new access point before you break the current connection. That is the fastest way to do it.
But you have to dissociate first because
No,
the access point
you
you're
don't
connected
have
to
to.
has to then send a key
No, you don't
if you're
have
doing
to.
fast roaming. You're
You
doing fast roaming.
associate, you pre-association. You do pre-association with a new access point, and then you sever the current connection when you really got associated with a new one.
Right, but are we just talking about multicast like connectivity like to clients?
Yes.
Because multicast over Wi-Fi, the how you hold buffers is you send the data out at the minimum data rate, and the client just has to buffer that. And then keeping a time sync is almost impossible.
Yeah.
It is
It's on the
access
client's
point.
clock.
Yeah.
Really.
Yeah,
It is-
because
yeah.
there's no way to keep a client clock synced
Yeah,
wirelessly. Wi-Fi wasn't built for that.
Hisham, I
Yeah.
think this release of buffer and everything is more for the audio video. It is not like for the Wi-Fi connection and all of these things.
Yeah,
So
yeah,
two separate
Yeah.
things. Like that it
yeah.
doesn't apply to TCP and UDP
And
packets.
no one is doing time sensitive AV work over a wireless connection.
Yes. That's like, and I was actually wondering, is the time sync going all the way to Wi-Fi? Because there are some new Wi-Fi
Yeah,
protocols
that's
with
the
hardware
question.
timestamping and everything.
That's the question, yes.
Yeah. Is there
Because
anything with that or not? Like Tom?
Nothing
Not aware of.
nothing that we've started developing.
Okay. Yeah, but that's really new right now.
And
Yeah.
it's super new. Yeah,
Yeah.
I'm not sure any products that have taken it up yet.
Yeah. No, I'm actually testing the 210 XAX things to see like how they're performing, and so far, like we are in like lower microseconds. So like
That's pretty cool.
yeah, I mean it's pretty cool, but then line of sight, and I mean
Yeah.
like I've been just playing with it like last 6 days, not even a week.
wow. You are looking at .ax, Ahmed, that's great.
Yeah, and then the problem is I don't have there's no PPS in and out in these Wi-Fi things. So, but there's PTM. So I'm PTMing them into a I210, and then sorry, a 226, and then the 226 has PPS, and I'm checking the PPS. But I mean, you're looking at it after there's a PTM sync, right? So it's going fun.
Yeah, I know. And the other thing, Tom, um, sometimes access point keeps data
Yes.
while the guy is roaming and then release it.
Yeah.
There's a time gap here. It's not simple, believe me, it is not simple.
Yeah.
It requires
I think
lots of
that is
thinking.
really out of the picture. Like the buffer
Yeah,
for Wi-Fi data,
Yeah.
basically data transfer and everything is out of the picture. This is an AV thing, Yeah.
Yeah. I will say that once Wi-Fi 8 hits,
Yeah.
that's when I think this
Different
time
world.
sensitive Wi-Fi will absolutely take off, because
Yeah.
then you're doing multi-band roaming.
Yeah.
And so then you can have clients that are associated on 5 and then roam to 6 on a new AP and keep both links active at the same time.
Mm.
So if you're able to keep both links active and you never truly break,
Mm.
that should allow you to keep timing a lot tighter.
Yeah.
That'll be cool.
I would appreciate, Tom, if you look at time sensitive networking for wireless. Lots of work is done in this area. I will send you an email with details.
Sure, please
Yeah.
do.
Yeah,
Awesome.
this is huge amount of work is done.
Bob, do you want to add something?
Well, I was just listening to the conversation.
Mhm.
What strikes me is that there's a company that delivers streaming audio video over Wi-Fi every day called YouTube. But what makes them different is that if, Ahmed and I are watching the same YouTube stream, they have no interest in coordinating his stream with
Right.
my stream. And what your challenge, I think, Tom, is making that last link of the synchronous release. And this, of course, comes from the fact that YouTube is sending different unicast streams to two customers, right? Whereas,
Exactly.
in your network, you'd be sending from one, multicast source out through a distribution tree to all the endpoints. Yeah. So it's harder.
Yeah.
Much different problem.
Because
And that's
it's
why
correct.
AV over IP is so interesting, because I've done it before where I've watched multiple YouTube live streams on multiple different devices, and they're at different timestamps, off by seconds, whole seconds.
Yep.
But if you have an AV over IP solution, then you have one stream that's then multicasted out within your LAN, which is much easier to control, and that's usually much, much tighter.
Yeah.
Yep.
Hisham,
Uh,
was the residue?
sorry, I have to lower it. Thank
Okay.
you very much. Yeah.
You're
Sorry,
welcome.
I'm sorry.
No worries.
Confused everybody.
No
That is
worries.
an interesting discussion, Ahmed. Excellent meeting. Thank you very much.
You're welcome.
Really.
Yeah,
All right.
thanks for inviting me.
All right.
Thank you,
Any
Tom.
more questions, David?
Oh, yeah, and another one related to doing it over Wi-Fi. My understanding was, and I came across this because there's a lot of open source projects now of using Wi-Fi, Bluetooth, other ambient signals to see through walls, and even triangulate broadcasters. Can't that also then, in combined, be used to do very decent time synchronization? Supposedly, some of these even like $5 or $10 low-cost boards can get the carrier phase measurements. You're talking like nanosecond level details.
It could, yeah. The real challenge will be finding a way then to synchronize that back to whatever is sending the signal. Like, it's one thing to be able to triangulate the client in space. It's another thing to be able to make the client then recognize that live time delay, and then be able to compensate for it both on the client and the AP level. So I think we're closer. I think we're closer than we have been. And I think one of the big technologies that nobody talks about really is the Wi-Fi location finding tech. 802.11az is like the latest one, and that's promising, like, I think maybe 10 centimeters of accuracy. But if you think about it, 10 centimeters of accuracy from just an AP or two APs, well, that must mean incredibly tight timings that you're able to pull.
Sub-nano. Yeah.
Yeah. So, and that's just the Wi-Fi 7 spec. The Wi-Fi 8 spec should be even better. And so, yeah, I think the time is right for a tight time sync protocol over wireless. The real question is going to be dealing with everything else on the access point. I've had good results with multicast video over Wi-Fi when nothing else is on that channel and nothing else is on that AP. The moment you introduce anything else doing unicast or at a different data rate or with any sort of background congestion, that's when it starts to fall apart. So that's really Wi-Fi Alliance's big question is how are they going to deal with that going forward?
No, we have actually, I mean, I have two co-founders. We have a startup actually that we bring it down to like sub-nanosecond, and we use wireless interferometry. Companies called YY Stamp. So look into it. So I mean, we have papers, we put everything. It's like basically we have two carriers. One is slightly off by the other one, and we do DMDT, but in wireless. So
nice.
That is cool.
I'd also be curious too, have you looked at potentially just building your own Wi-Fi access points specific to the case of AV, where you're basically repurposing it to encode it, but you're not doing the full details of the protocol. You literally just spin up like a software-defined radio and just blast out deterministically without even reading anything on the RX side, just to spit it out.
Well, that's sort of interesting because that you mentioned that, because that's how we got started as a company, was doing point-to-point radios
Mhm.
built off of basically consumer level Wi-Fi chipsets, and abusing that, modifying the firmware to be able just to go really long distances and then adjusting time sync so that those radio links would work. So it'd almost be going back to our roots if we did something like that.
Yes, amazing.
Yeah,
Because the
so
advantage of that too, then, is you don't have to use the off-the-shelf chips. You can do it that's super custom built to completely eliminate all the issues you mentioned. You may find of, well, what about other protocols or unicast, or just say, no, we're just going to broadcast on these end channels and just spew it out. And I actually don't think it would be that difficult to prove a concept.
No, I mean that's how a lot of wireless mic setups work anyway.
Yeah,
I just did a setup in a convention center, and I had to channel around some wireless protocols that were being used by TV cameras and microphones, and so they're already doing the same thing.
Related to that,
just for their own little endpoints.
I was curious too, for your EAV bridge, does that use a standard protocol, or is that a proprietary one that's being streamed?
That's Dante Video.
Gotcha. Okay.
So
And then
go
ahead.
no,
I was going to say,
David, the AV bridge, your question is correct. It is not a standard bridge. It supports AVB protocols and quality of service. It is defined
doesn't
by
support AVB.
one TSN group. Yes, it is not a standard. It has some other features. And by the way, Tom, during the 802.1 TSN group, time sensitive group, we spent lots of time working with 802.11, the wireless group, on something called time synchronization function. Look it up, TSF, time synchronization function, which is the function defined by 802.11 to synchronize timing for all clients associated with access points. Time synchronization function.
That's cool. I'll look that up.
TSF, timing synchronization function in TSF and 802.11.
Ahmad, I have one more quick comment.
Huge amount of time to finalize this.
Yeah. You had one more comment?
Yes. If this goes back to the topic of Wi-Fi over radio, like, or excuse me, multicast over radio, like a Wi-Fi, and something that's underappreciated, I think, in the community is that when you are configuring an access point, there's a setting in many that I've used for what I would call a multicast policy. And policy is really the operative word here, because when an access point is dealing with 10 different endpoints, unicast, the access point and the endpoint can negotiate an optimal trade-off between throughput and reliability. But when you have that one access point sending a packet once and being delivered to 10 multicast recipients in the same RF broadcast domain, now the access point has to make a trade-off decision across those 10. It can send it very quickly, use very little bandwidth, and stand the chance that 8 out of the 10 miss it because they're behind something noisy. Or it can choose to eat up a lot of spectrum and a lot of space and a lot of time, send it very slowly, methodically, 10 out of 10 get it, but the total amount of multicast bandwidth and the leftover unicast bandwidth is compromised for all the other stations on the network. So whoever is configuring the access point has their hand on a knob that relates the time and spectrum usage to the reliability of multicast delivery. And the frustrating thing as a person who's administering, especially a stadium, there's going to be a guy right next to the access point who's saying, turn it up, give me faster and faster video. And a guy who's way far away saying, I can't hear half of your packets, right? Because you're not, modulating them slowly enough that I stand a chance of picking it out of the noise. It's a really difficult challenge in the radio space.
It's a tremendously hard challenge. Controlling what we call the minimum basic rate.
Yes.
That's how the multicast travels. Is the access point will say, okay, I need to get packets out to these 10 people. I don't really know. I don't really know the quality of the network. I don't know if they're going to be able to receive it, but I'm going to send it at my slowest rate. And if they get it, great. If they don't, also great. Now, there is another knob you can turn or another switch you can throw to convert all that multicast to unicast traffic.
Oh, really?
So your clients can negotiate that higher data rate.
I didn't know that.
But if you convert things to unicast, then the client can say, "Oh, I didn't hear it. Can you retry that?" And then that can eat up even more bandwidth.
Yes. Yeah.
So yeah, multicast over Wi-Fi is horrifying, and especially though the worst offender is multicast DNS, because
Oh, yeah.
that is a significant amount of low bandwidth packets.
Yeah.
But every single device on the network wants to advertise its capabilities. Every single device is sending MDNS.
Yes.
Usually when I do public Wi-Fi build outs, I just kill it entirely.
Yeah.
Even
I've
for a
noticed that in my
school.
homeland. There's a lot of MDNS traffic, and it goes
There
over
is.
Wi-Fi. Yes.
And even on the corporate network, it scales like that. I did a school in Texas, and they had HP printers, and those printers were sending 10 MDNS advertisements per second that they were printers. And it was going out over Wi-Fi, multicasted to every single device on the network. It was bad.
You need a rate limiter somewhere, like a policy rate limiter or something like that. Yeah.
Yeah, absolutely. And even if you do, like the question becomes, do you even care? If you're running a public network, do you really care? Do you want devices to be able to discover each other? And usually the answer is no. So it just becomes easy to just turn it all off.
Yeah. Yeah.
All right.
Just one more. I thought I'd mention that could be of interest. I was looking at the cost of the AV bridge. So just full disclosure, I've always wanted one of these for my home so that I can have all the TVs and then all the output devices and not have to worry about which one's plugged into which. Right. Sort of the holy grail. Once you got to 10 gig, it was possible. One thing I would check out potentially is there are these relatively low cost HDMI to CSI interface boards. And so these are what drop down to the standard camera interface. And you find a lot of embedded systems. And the reason these are neat is that's also what's on the Raspberry Pi. So these got very popular years ago. I actually had a friend even who ran a company doing this, where they built these IP KVMs based on Raspberry Pi and these. This could be another way to create a lower cost EAV bridge. And I think they're capped out at 60 frames at 1080p. So you may not be able to go to 4K. But something worth considering. I don't know what your bill of materials are in the EAV bridge, but if you ever want to try to get it down, even down to like the consumer realm, it could be very interesting.
Oh, that's interesting. That's cool.
And then you already have 1 gig. They already have some degree of PDP support, though a lot of people on this call will rip our hair out about what level and where it's being timestamped. I think on the Raspberry Pi 5, it's in the interface chip. It's not in the Mac itself. I forget what they call it, the RP1. But it's pretty decent. So for some of your applications, it could be an interesting one. And actually, I just noticed your EAV bridge. Do you also forward USB?
Yes, we do.
Okay.
So we're going to have full control over that shortly. But yeah, we forward USB and we also forward the IR port. I'm also trying to see if I can use that IR port for serial as well.
Gotcha. And so that's the other thing I would mention. Check out the Pi because they can do both OTG mode and regular. And so they're great for doing things like Ethernet USB bridges. So you may be able to get a relatively low cost, bill of materials under $100. I don't know what the cost of scale are, but could be fun.
Yeah, if you do like a Pi CM, yeah, because getting real Pi boards now is a bit crazy.
Yep. And to try to use as little RAM as possible, courtesy of our AI brethren who are buying up all the chips.
All right.
I put the RFC 9119 that really describes the issues related to multicast for Wi-Fi networks.
Yeah, let me look at that standard.
Yeah. Anyway, I got your emails or tons of information about it, but I don't know what exactly you are doing in the company. Interesting discussion anyway. I like it.
Very much.
And I just love my email in the chat as well. I have students working on projects exactly like this all the time. So if you ever want to partner, it could be fun. whether it's doing
Oh, okay.
the Wi-Fi or doing it. I'm with UNIFi. So,
Oh, right on, man. I'm in Illinois.
oh, perfect. Where about? You in Chicago or?
I used to be in Chicago. Now I live downstate.
Okay. Well, if you're ever in town, if you're ever in town and you need discounted parking down in the West Loop, let me know. I'm 5 blocks from west of Sears Tower. So,
Oh, right on. I mean, my office is in River North, so
oh, perfect.
yep.
Yeah, feel
Cool.
free to drop by the lab any day. We have a lot of this stuff set up as well and for other timing experiments. But I did have students working on something similar to this, but the construct was so that if you had like, I'm not going to name the vendor, but your different server vendors, if they need to help troubleshoot for example, AI cluster, the idea was to have a Raspberry Pi based device with like a 5G modem that they could pop out the hard drive so there's no data loss, then plug this little gizmo directly into the server and then be able to diagnose it, control it, use different ISOs to boot it up, ideally type into JTAG. And so it was vaguely in a
Yeah.
similar sense, but not just
Remote
for
crash
pure
card.
audio video. Exactly. It was really a remote crash card. So this poor guy didn't have to keep flying around the country to different data centers just to
I like
troubleshoot
it.
things.
I like it.
Because to think of it, you guys may be the perfect company to productize it. So if you want to collaborate, I love doing the POCs. I don't want to deal with the commercialization at all. So, but
All
it's
right.
fun.
So
Hey.
see, I told you, Tom, it's gonna spill over the top of the hour.
You're right. You're right.
And anytime we see more companies trying to get into PDP, I think we're all for it. And it's just, how can we help? How can we help? Here are tidbits,
Yeah.
different components,
No,
different
no,
things you can
please.
look at off eBay.
Please, we want tidbits because the AV industry is interesting. Like I love doing AV work, but there's so much more that we can and should be doing with PTP. So being able to hear from you guys is super helpful.
So one thing to check out as well, you can get them off eBay now. Arista, because they were the de facto switch of choice for high frequency traders. They've been doing this very well for years now because they have some of the most aggressive anal retentive customers, like Bob and I trying to measure everything to the sub nanosecond. They even have some switches that can timestamp Ethernet frames sub 100 picoseconds. They use time delays and custom
Well,
FPGAs.
let's have
Offline.
like Ubiquiti's products go to White Rabbit. That would be great.
I'm not touching that one. I'm not getting in trouble. But if you're just looking for what a similar competitors or vendors in your space have, you can just buy some of these for literally a few $100s. So they have a lot of the different PDP modes and settings, and you can see some of the features they have. Even things like port mirroring or timestamp port mirroring is useful if you're trying to capture everything into the nanosecond and you got some packet. But they're nice because they're old enough now. This technology from Arista, in some cases, these are now 10 years end of life. So you can get them pretty cheap off eBay. Check out like an Arista 7150 or a 7050.
Wow.
Yeah,
So
that's
this,
really a
uh,
good one. One line of command like on EOS, and you get transparent clock enabled. What was it? It was like so simple, something, and then that's it. And it gets enabled.
Yeah, and then you can see all the features and also all the things they added
Fantastic.
over the years in response to customers of like, we want to measure this, we want to see this, we want to do this strange thing, which no one would
Yeah.
ever expect as you're bifurcating the network or other things.
And
But
there's a cheaper one, 60, 66 something, 60, 80. Which one is that one? The one that's like copper. That one is really also very
like the
nice.
7050s you can get for like $50. I think I have two of those
Yeah.
for the 1 gig ones. And then they
Yeah.
have like a 4S50 plus uplinks.
Yeah.
But it's just interesting to see because sometimes those are cheaper to use, ironically, than if you're trying to get like a dedicated new embedded systems one, even if it's just 10100 Ethernet, that still may be the better way to go. If you do get one, though, just a warning, if it's on your desk, there are firmware settings you can use in the command line to turn down the fans. Otherwise, you will go nuts very quickly, especially you get the timing specific
I've got
one.
plenty of X cast off server gear. I know about the commands to turn down the fans.
Yep. But another thing they have, I don't know what your configure system is, but they're really good about doing like DevOps and infrastructure as code. So you can actually configure your whole network automatically and commit it to version control and know how it is. And then also a lot of different monitoring tools to get continuous streaming of metrics. So that could be a useful inspiration. They tend to do it better than historically what I've seen from some of their competitors.
Oh yeah, for sure. I'd be remiss if I didn't point out the fact that we now offer infrastructure as code as well. So we now offer, we have our own developer site, not only with an API, but being able to get out Ansible playbooks.
Oh, perfect.
Awesome. Awesome.
Related to that, on your switches, do you run, I assume, some kind of x86 or Raspberry Pi or whatever internal server? Typically, these tend to be like Linux based. And
Not on any of our servers. We just have a lightweight Linux distro that just runs a little management computer, like nothing crazy. The only switches that are x86 based are like our big boy aggregation switches.
okay, that'd be another one to check. Is do you give customers direct access? Can they run, for example, virtual machines on it or others? Sometimes that could be useful for
You have
troubleshooting.
SSH access to them. You can do whatever you
Yeah.
want.
Yeah, I was gonna say that the ECS aggregation does have that. In fact, that's how it's built because it's running Sonic. So
Exactly.
if you're familiar with that, yeah.
Nice. Very
All
cool.
right. Perfect. So let's thank.
The one comment I have, Ahmad,
Okay.
just simple comment. If you want to use
Let's go. Let's go. Sure.
DVB bridges, you should use, and PTP, you should use the profile, which is 802.1 AS. Not BTP directly, it's a profile for AVB bridges.
802.11 AS.
Yes. No,
Interesting.
802.1 AS. 802.1 AS.
Oh, 802.1 AS. Okay.
That's what's used for AVB bridges. But you know, I always get impressed. You're a professor with too much hands-on experience.
It's my curse. And 100 interns a semester. I mean, students.
I'm really impressed. I didn't never seen a professor, especially in a big university like yours, who just too much hands-on. Come on.
The trick is I'm technically not paid to do any research, so I just get to play with whatever I want. And so it's whatever's cool or gonna somehow help humanity. Or just connect my Xbox to multiple rooms. So as always, Ashab, you're too kind.
Oh no. I send you a paper also.
I'm happy to check it out.
All right. So let's close the call. And
thank you very much, Ahmed. That's a really excellent call and triggered.
But before we leave, just introducing, like, basically in 2 weeks, next speaker will be Bob. Bob, do you want to quickly say what's the title and that's it?
Sure. It's effectively a report on the research I've been doing over the last mostly 4 months into sub-nanosecond time acquisition using GNSS.
Wonderful.
So, yeah, receivers.
Cool.
And
perfect. All right. Again, thank you again,
in 2
Tom,
weeks.
for this informative presentation. And again, as usual, we'll have the recording and the slides on the wiki. All right.
Excellent.
Sounds good. Thank you, guys.
All right.
Bye, everyone.
Thanks, Tom.
Take
Thank
care,
you very
everyone.
much. Bye-bye.